Hi, in this video, I'm going to explain Mlt experiment number 7. For this, first we have to import some libraries and install some packages, and uh, and then we have to load the data set. For that, we are using data is equal to pd.read csv and csv file name inside the brackets. And then we have to find the missing values. For that we are using data dot fill now, data dot mean, and it is to replace missing values with mean, and it ensures no null values. And then data scaling. For data scaling, we are using scalar is equal to standard scalar, and x scaled is equal to scalar dot fit transform of data. If it is standardized data, the mean is equal to 0 and standard equal to 1. It is important for standard based, it is important for distance based algorithm. And then set FCM parameters. To set FCM parameters, you are using n cluster equal to 3 and m is equal to 2 and max iteration equal to 150. N cluster means in cluster is number of clusters. F M is fuzziness. It controls overlap if m is equal to 2 standard value, and max iteration is a number of iterations. And then visualize data. To visualize data, we are using a plot.scatter and data.iloc and data.iloc. For to find visualize data, it is to plot first two features, and it shows raw data distribution. And then find best number of clusters. To find the best number of clusters, we are using for k in range, and FCM is equal to FCM of n cluster equal to k. It is to try cluster from 2 to 5, and it calculates the Silhouette score to find if it is high score, it is better clustering. And then plot Hasselhoff score. For this, we are using plt dot plot, cluster scores, and x-axis is number of clusters, y-axis is number of Silhouette score. It helps to visualize or visually choose best cluster. And then partition coefficient. To find partition coefficient, we are using FCM partition coefficient. It measures fuzziness quality, and the higher value is better clustering. And then select optimal cluster. To select optimal cluster, we are assign optimal cluster is equal to 3. It is based on evaluation. It choose best cluster count. And then final clustering visualization. For final clustering visualization, we are using plot.scatter of x's and C labels. It shows cluster with different colors. There are different colors. It shows the clusters. Each point may belong partially to multiple clusters. And then cluster centers. To find cluster centers, we are using center is equal to FCM dot centers. It is to display center of each clusters. And to save output, we are using data dot to CSV, and then file name if it index is equal to false. It is to add cluster label to dataset and save files for further use. Thank you.